the summer 2026 RC. Thank you, Brenton. Brenton is recording this. Once we are done, we'll post both presentation material as well as the recording sessions in the appropriate sites. I welcome everybody that came in here to sit in this conference room and spend next 2.5 hours with us to help us to show. We'll showcase what RC West and the TOPs have been working on in preparation for the summer 2026. And from both the tools point of view, tool improvements point of view, procedures point of view, and communications point of view, which is really key for us to have a successful summer operations. There's a lot of great presenters. We got Amber Motley, our Director of Short-Term Forecasting. She's going to talk about the upcoming summer weather forecast from a regional point of view and things that we would see from a forecasting and load forecasting, generation forecasting point of view. And we also have Deputy Chief Jeff Funitis from CAL FIRE, who's going to talk about the Western U.S. fire risk outlook, right? And this is really critical for us. No matter how much we prepare, fire can throw a big curveball to summer operations, right? So more information will help us from a preparation point of view, from a coordination point of view. And after that, we have Brittany Andres, who is the Senior Resource Adequacy Analyst from WEC. WEC does a great job every year looking at overall WEC region generation assessment, resource outlook point of view. I know each balancing area does their own assessment, but WEC looks at overall and let us know from an operations point of view what we expect, what things that we need to expect from that point of view. So we have that. And then after that, we have the RC West operations team, including myself, Samson, Cody, and John. We're going to talk about all the procedural changes, tool changes, and the training that we have done to our operators, RC operators, in preparation for summer 2026. Once that is done, a public session will end at 11 o'clock. From 11 to 12, we also have a closed roundtable from a balancing area. There's going to talk more details surrounding what is the expected changes, from a transmission point of view, generation point of view. It's a closed session. Each of you that's part of the BAs and TOPs and the RC West footprint should have received a separate WebEx link. We'll use that link for the closed session once the public session ends. If there's anything else, I'm Raja Tapedobla, Director, RC West Operations. Again, thank you for joining this call. We'll start with Amber Motley's transmission outlook. You can try. Presentation is there.
Good morning, everybody. All right. Before I dive into what 2026 is going to look like, we'll walk through a little bit of 2025 as it relates to summer observations, as well as the winter and spring season. So as we were in 2025, we were really in more neutral conditions in that ENSO region, which is the equatorial plain sea surface temperatures. And we had, going into the summer and even leaving the summer in August, this is a graphic of the sea surface temperatures across the Pacific Ocean for August 1st of 2025, we saw below normal temperatures right along that coastline of California and the western footprint. Those two areas will play a big role in the forecast for the 2026 summer outlook. So will be regions that we're looking at as we go through the next couple slides. But overall, the temperatures for June, July, and August of 2025 had the highest heat concentration in the far Pacific Northwest, as well as some of the desert Southwest regions. And we saw a reprieve in the coastal areas of California, northern and southern California, but not far northern California, as well as the inland areas and parts of Nevada. Precipitation-wise, we did not have a very strong monsoon season across that desert Southwest period, so we did see below normal precipitation as we went through summer of 2025. In comparison to where the forecast was that we gave you in this meeting last year, we saw observations that matched really well with where the heat setup of the Pacific Northwest, as well as those more desert Southwest regions, and where it kind of ended in the eastern United States. The one area that we did see cooler temperatures than what were forecasted was those inland areas and those coastal areas along the California footprint. Now transitioning a little bit into the winter and the spring season, which also plays a major role in where the drought conditions are continuing to evolve. We had the top 4 warmest winters, December through February, across the West. And of those top 4, 7 of 11 states within the WEC footprint had their warmest winter on record, and the remaining 4 of those states, it was still in their top 4 warmest winters. With that, we also transitioned very quickly into March and springtime period with a very record warmth across most of the Western footprint as well, and continued to see those drought conditions evolve. That also played a very big role in the snowpack, which I'll talk about a little bit, and where that snowpack condition is across the Western footprint. In April, we did see some transitions where we finally saw precipitation come in more in that above normal wet area, whereas indicated by green here. So we did get some precip, but it was more in the form of rain at that point than snow cover. And then our temperatures for that April time period were more moderate than we'd seen throughout the rest of the winter season. So with the winter conditions in combination with what we saw during the spring, we see significantly below normal snow water equivalent, which is kind of like how much snow and snowpack is left up in those mountain ranges to be able to melt over that spring season and then run down into the reservoirs, which are depicted on the right-hand side. The snow water equivalent graphic here is taken in April. This is mid-April, so it has depleted since then, of course. And then the reservoir conditions were taken as of the end of March. A few things to weigh in, and we'll see this in the graphics later. The areas that have the least snow water equivalent are in the far desert Southwest, in that lower Colorado River Valley. But you see throughout California and much of the Western states that you're well below 50% of snow water equivalent that you would expect to see during that time period. You do see some hydro conditions, and this was depicted by the graphs in the earlier slide, where we did get precipitation and snowfall in that far, far northern region. They do have 70% of normal as of that April time period, so there is some precipitation up in that area. Leading into the reservoirs, so the reservoir conditions, specifically the 2 larger ones, Powell and Meade in this area, they are less than 50% of their capacity, with minimal snowpack to continue to run into them as we head into the hydro season. But for the California footprint area, because we had a mix of some snowfall, then heat, then some rain, the reservoir conditions in California are at or above normal at this time of year. They just have limited snowfall to come down throughout the remainder of the year, but they are very healthy within the California footprint. Within the far Pacific Northwest, it's a little bit of a mix, and they do have some more snow to melt down as we go into the early part of the summer season. Drought conditions. So we saw drought areas expand across the West as we went from 2025 into 2026. There is some reprieve you see. So in 2025 in that far, far Southwest Four Corners region, they did get some moisture over the winter season that helped them in reprieve, but it really shifted where the drought conditions were more into the central period and away from Texas. So with that, the drought conditions will play 2 roles as we pick what we call multi-analog years, sim years, looking at all the conditions throughout and pick the summer forecast. The other thing that will go into the summer forecast in the multi-analog comparison is the sea surface temperatures. Up on the top, you see the sea surface temperatures in April of 2025 and April of 2026. You can see 2 things that really changed from what we had as we went into the conditions of 25 versus 26. You're seeing warming across the equatorial plain. We are transitioning into El Nino. The strongest El Nino won't happen until more late summer, fall, and into winter time period. But you also see a very large transition of the sea surface temperatures along the coastline for the western United States. The sea surface temperatures along the coastline have a bigger impact to summer forecast conditions for most of the west footprint than what the transition is for the equatorial plain. In August of 2025, we still saw that there was some warming in the sea surface temperatures, specifically up in that Pacific Northwest area. But where you saw the temperatures come in cooler for the 2025 summer is where you saw the sea surface temperatures be still below normal in that August of 2025 time period. All right, so with all that information of drought, sea surface temperatures, the transition of what those sea surface temperatures will continue to be as they warm this summer due to the ENSO phase, drought conditions, and then recent years, the similar years that we're using to form our multi-analog forecast is 2015, 2018, 2022, 2023, and 2024. I'm sure as grid operators, these are notable years for a few of us. 2015 is the most matching sim year to the sea surface temperature coast. But you also see that some of the other years that are popping in here, 22 and 23, have also similar matches as you look at the ENSO plane, as well as where the drought conditions are setting up. We see that the drought conditions setting up really help indicate where that high pressure ridge, and high pressure ridge is where you hear the news called the heat dome when it wants to set up. The high pressure ridge is where it likes to set up during the summertime period. It oftentimes aligns with where you see the heavier drought conditions in the plains. So one of the things this year that is also different than last year is those drought conditions have shifted a little bit from the more southern, eastern part of the western footprint into more of the central footprint of the western area. So with that, that means that you can shut off the offshore or the onshore flow a little bit more from those coastal areas and see bigger ridges setting up over the western footprint for more continuous heat than what we've experienced. Last summer, we were able to have heat maybe in the Pacific Northwest, but not Southern California, not in the desert Southwest, or the desert Southwest was hot, but maybe not the Pacific Northwest. But this year looks like there is the possibility to have more of a west-wide event. Those warm sea surface temperatures, like I talked about, will really impact the coastal area to see above normal temperatures. So the overall forecast here, this is how many degrees above normal for June, July, and August that we are expecting to see. The dark red is 2 degrees above normal. This is taking into consideration the min and the max. And you see that it's concentrated very heavily into Northern California and the Pacific Northwest region. But you see the other regions of the West still seeing 1 to 1.5 degrees above normal expected. The one thing we do see on precipitation side, and this is also an indicator of these sim years, is that you do have a pretty healthy monsoon expected as we head into June, July, and August, and you'll see some of that impact the desert Southwest region as they have a little bit of reprieve in their overall anomalous temperatures. Couple more slides taking it all together. These are issued from 2 other models, the Climate Prediction Center and their overall model, as well as the IRI model, just looking at the probability of above normal temperatures. The previous graph that looked at how far above normal we are expected to go, looking at the multi-analog years. This is the probability of the chance of being above normal. So you see that the IRI model aligns very well with the areas of the highest anomalous temperatures, really focused in Northern California, the Pacific Northwest, and into that central region. Also aligns really well with where those drought conditions in more of the central area still remain. But you do see that there's the probability of above normal temperature through much of the western footprint, carving out a little bit of that area for the monsoon conditions to come in. It does suggest that we will be off to a hot start this summer when we look into the June timeframe. And that we'll continue to see increased chances of coastal heat ups. Transitioning a little bit into the late summer season and early fall, we still see increased odds of above normal temperatures throughout the western footprint, but you do start seeing some easing where the highest chances of above normal temperatures remain in that far Pacific Northwest area, but you see reprieve around the Southern California area and the coastline as you see monsoon conditions go into that above normal state. We'll continue to watch the outlook for August, September, and October because it is pretty far out right now. But we do still expect to see above normal temperatures really centered on the Pacific Northwest. So the big takeaways for this summer is it does look like a hot one. We're really watching the sea surface temperatures across the coast. I think last year the coastal region really got a break in some heat events. It looks like they'll not be so lucky this year. But I think one of the things that we have noticed when we do have west-wide heat events is that they do start showing themselves in that 10-day time period. So we start getting an indication that that ridge is going to build up. It's going to be across a number of the Western entities, and we can start coordinating and collaborating at that time. So we'll continue to watch and alert within those 10-day windows as we start seeing some of the stronger heat come in. And with that, I will take any questions. And I don't know.
Thank you, Amber. That summary that you made looks like we're going to have higher loads, and there's more chances of fire as well. Fire risk is increased too, right?
I didn't talk about fires. I figured Jeff could talk about them a little bit more, but I have a feeling he might say something like that.
The second bullet, both drier than normal risk as well as the rainfall in desert Southwest, right? That lightning can cause fires too, right?
Yes.
Any questions for Amber from anybody online? From anybody here?
I don't see any hands up.
Yeah. Thank you, Amber. Thank you. Thanks, Amber, for that detailed forecast, which should help for our summer operations. Next, we can move on to CAL FIRE update. Chief Jeff Funites from CAL FIRE. I think I saw him online. Jeff, can you make sure that your audio, can you confirm everything is working?
Yeah.
Good. I can drive.
Good morning. Can you hear me okay?
Yep, we can hear you okay, Jeff. So I will drive the slides. So let me know when you want me to move, okay?
Great. Okay. Well, good morning, everybody. My name's Jeff Fuentes. I'm a deputy chief with CAL FIRE. I'll do a quick high-level summary of kind of the 4-month outlook. I'll quickly go through. Amber did a great job already, covering kind of the current water year drought status, but then I'll kind of try and correlate that with kind of impacts on the vegetative fuels and what to anticipate or what's forecasted as far as significant fire potential through August for the West. So next slide. So, as mentioned, very warm winter, not just California, really across the whole West, averaging, 2 or 5 degrees warmer than average, which is a lot over such a 6-month period of time. Really standout month, as was mentioned, was March, record heat and no precipitation really statewide. I think we were 10 degrees or more. So kind of really unprecedented for the month of March in terms of the degree of warmth. And then, with the water year flashback, right, looking at October 1, you can see that lower image on the scale, showing the percent of average precipitation. The blues and the purples are above normal, oranges and reds are below normal, and the green is near normal. So pretty mixed bag by and large, typical season in terms of the amount of precipitation. Obviously, some winners, some losers. LA Ventura's, Santa Barbara counties, and some of the northern deserts got more precipitation. Conversely, a lot of drier areas in the north, also Southern California, as well as Western Oregon, Nevada, and Southwest. So fairly typical, but how we got there was definitely comprised of some very long periods of warm and dry, interspersed with a couple shorter duration windows of significant storminess, and not a lot of warmer storms, so not as much snowpack, and the snow that we did get melted, and Amber already kind of touched on that. So next slide. And that just getting into the drought, obviously Central Southern California, not really in drought conditions, but we're starting to see the reemergence of moderate drought in Northern California, with that likely expanding June through August. Seeing widespread moderate to severe drought with even extreme to exceptional drought, in those Great Basin areas in Utah, along the Nevada-Idaho border, kind of that one of the driest zones there in the west. And for the southwest, all New Mexico, at least at a moderate with severe drought, kind of expanding into Arizona. And drought development is very likely there. So next slide. So when it comes to a wildfire environment, a critical element is the dryness of the vegetation. So we look at fuel moistures of the vegetation. So how much water is contained in both those live and dead fuels. It's really an important driver of fire potential because it directly influences how easily the vegetation can ignite and then also sustain combustion. So what we're looking here is what's called the 1,000-hour dead fuel moistures. And we're looking at Northern and Southern California in these images since the beginning of the years. And these are our heavier fuels. And if you haven't ever seen these charts, they're a great tool that are available from the Geographic Area Coordination Predictive Services. Very useful. The blue line's depicting the current year. The gray line is the average. And the red line is record dryness levels. You can see the first couple months we had those wet periods with those dry kind of periods in between. Then we got into the month of March where we just really, tanked in terms of dryness of those heavy fuels. And then April we had some precipitation, cooler conditions, which brought us closer to average. But then, as most of us have experienced recently, some dry, windy conditions over the past few days, and also those hot conditions that Amber was mentioning that were forecasted for as far as the temperature outlook. Really anticipating these to dip lower moving forward. And then really dependent upon any kind of monsoonal moisture that we may get, at least for Southern California, and how that'll impact the fuels. But right now, where we're at, off to a very dry start as far as the dead fuel moistures. Next slide. So the live fuel moistures, are really interesting stuff as well this year. A lot of it's elevation dependent, but we've got a lot of areas that are already cured out, and if not already are, will be soon. A lot of them are peaking now. Pretty much out of dormancy everywhere. You're looking at an image here from the Alert California network. It's Noche Mountain, which is in northwestern Fresno County. Normally this time of the year, we'd be starting to see the low elevation grasses cure. But this year, a lot of the grasses were already, really cooked weeks ago. You can see, April 13th, the grasses were already drying out. And then if I were to take an image of it today, it would be even browner than it is in this picture. So way ahead of schedule and atypical for this time of the year. So that can really be attributed to that warmer than average March that we had that kind of just set all this off, and really put us into, an early shoulder season, as we call it. And we've been getting a lot of fire activity because of this already. In the state of California, several thousand acres have already burned in the past few days, particularly in Southern California. We currently have fires in Riverside, Ventura, San Diego. So we're off to an early start. Next slide. So this next images are the 4-month significant fire potential. This is a product from the Predictive Services. And I'll kind of start with Northern California. So, we had that early season green up and the snow melt that occurred. And so we're staying in a kind of a normal status for this month, but moving into above normal potential across the region from June onward, due to those grasses getting fully cured, the vegetation drying out, increasing drought and the potential for heat waves. And one concern, obviously, too, with any kind of monsoonal moisture that we get in the south is what kind of moisture we get with that in the Northern California. If there's, potential high risk of dry lightning and things of that sort. So things to keep in mind. Southern California maintains normal. I think it's right there near kind of above normal fire potential, obviously this month, but they're saying normal for the entire period. And it's really due to the potential for those monsoonal moisture patterns and potential tropical remnant systems. In the Northwest, conditions begin near normal, but then shift towards kind of above normal potential as that early snowmelt and ongoing warmth and drying fuels kind of increases the likelihood of fire activity. The Great Basin, kind of temporary moderation of fuel conditions from the spring moisture, but faces, increased fine fuel loading. So those finer fuel vegetation. It has a historically low snowpack and rapid drying once warmer conditions resume. So as June transitions into July and August, above normal potential kind of expands across the high elevations and the lower elevations with carryover from those fine fuels. In the Southwest, above normal fire potential continues in May and June across most of the region. That's really driven by drought and warm temperatures, dry fuels. Kind of the exception is the far Southwest, with that monsoon onset expected on time or slightly early. July seems normal across most areas, except northern Arizona, which remains above normal. It is worth noting when I say normal that, especially in the state of California, normal is vegetation fires in the summer. So, there's thousands of fires that normally occur and hundreds of thousands of acres that burn. So I think it's worth noting that just because we say normal and it's not above normal doesn't mean that we're not going to have vegetation fires. So there's still a lot of fire potential, especially with the fuels curing as quickly as they did. Next slide, please. So just want to close out and make sure to highlight this. I think I've done it in the past here, but I think it's just a good thing to make folks aware of. So the Wildfire Forecasting and Threat Intelligence Integration Center in California, we have a new website. There's decision support tools, products for wildfire forecasting, fire weather information, and fire intelligence. There's two of the products here on the screen. One is a daily product that shows the fire size potential forecast, the 7-day significant fire potential outlook, as well as National Weather Service weather discussion, and then how that relates to the fuels and fire behavior from predictive services. So you can now go on the website, hit subscribe, and sign up and get these automatically generated to your email. Next slide. And that is all I have, unless there's any questions.
Hey, Jeff, this is Brian Murray, CAISO. First of all, thank you for the presentation. Appreciate you sharing this each year. Super helpful. Question I had for you, Jeff, was for staffing and resources this summer, any changes from what you had available to you for CAL FIRE in comparison to last summer?
All of our folks have all been brought on, essentially ready to go a little sooner this year. So I guess in the sense of that, we're fully staffed and ready for the fire year. We do have our C-130 aircraft fleet and Firehawk S-70I helicopters. Those are, now being able to bolster our air fleet to help with that response. I guess we we continue to be ready to serve the people and of California. So I think we're ready to go and we're staffed. Not a huge difference in the amount of staffing.
Appreciate that. And then media has been covering this lately, with the increased fuel costs. It didn't sound like there was going to be any impact in terms of Cal Fire fleet, firefighting fleet. Is that true?
Correct. Yeah.
Yeah.
With that should not impact our operations.
Cool. Appreciate it. Thanks, Jeff.
Yep.
Thank you. Jeff, let me see if there's any hands raised from WebEx. If not, I got a question, Jeff. I know you mentioned, right, there's an increased dryness. Have you seen in the last couple of months, March, April, May, have you seen any more fires compared to last year? I know it's not summer, but just curious from your point of view, have you observed more fires compared to last year?
Yeah. So that's a great question. So kind of where we're at right now. As of yesterday, we had 1,479 fires. Last year, this time we had 1,525. We've burned 40,000 acres, just under 41,000 acres so far in 2026. In 2025, we're at 66,000. So I guess in that sense, we are lower currently, but activity has really picked up within the last few days. And we're also below the 5-year average right now. The 5-year average is right around 2,000 fires and 23,000 acres. So we are, I would say, below that 5-year average. So hope that answers the question.
Yep. Thank you, Jeff. I know if anybody else, any of the TOPs would want to chime in as well. Definitely in the last couple of months, we have seen increased PSPS, right? So the number of PSPS events and related transmission equipment de-energization. So just curious if everybody's seeing the same thing, or is going to be expected more fire this season, more fire related events this season. So thank you, Jeff. Thanks for that presentation.
Yep. Thank you.
Hey, Jeff, one last question. Brian here again. Last summer, remember we talked about the retardant chemistry makeup. I think there were some questions from folks. Neil, I think this came up with PG&E last summer too. If utilities aren't able to, if a retardant drop ends up hitting some transmission lines, insulators, those type of things, and they're not able to get those washed fairly quickly when we have high temperatures, that some entities were having to actually replace those insulators rather than spend all the time to clean them. So Jeff, I remember asking you about the retardant chemistry, and it sounded like CAL FIRE had made a chemistry change. It sounded like a year or two ago. Have there been any other changes since then?
Not to my knowledge, but what I can do is I can connect you with our program, our aviation management unit, and they're actually, they know all of the makeup, and I can actually send you also some specs on of what that retardant is made of as well. So I'll make sure to put that down as an action item and to get that to you, because I understand the concern with contamination on electrical equipment and how that can be an issue.
Yeah, appreciate it. Thanks, Jeff.
Thank you, Brian. Let me see if there's any questions. No, I cannot see hands raised. If anybody from WebEx has any questions for Chief Jeff Unitas, please go ahead. Okay, I don't see any hands raised. Thank you, Jeff. Thanks for taking your time presenting us the good information that will help us for prepare this upcoming summer. Thank you.
Thank you.
Yeah. Next, let me see if we have Brittany Andres from WEC on the call.
Yes, I am here.
Okay.
Must be going a smidge early, but that's fine.
Yeah. Hey, Brittany, let me stop sharing and get your presentation. I know you sent me the PDF. It's a part of a separate package, but I'll open that file. Give me a second.
Great.
Okay. Brittany, let me know if you can see the presentation, the PDF file that I'm sharing.
I can.
Okay, go ahead, Brittany. Go ahead and introduce yourself, and then let me know when you want me to move the slide. Okay.
Will do. Hi, everybody. My name is Brittany Andrus. I'm a Senior Resource Adequacy Analyst with WEC, and we're here to talk about the assessment that we recently completed with NERC about the summer 2026 reliability. Can we put in the chat if I send it to, or can I put in the chat the website for the recently released SRA, Raja?
Yep.
Okay,
Brittany,
great.
please go ahead. Thank you.
Okay, great. So yesterday, NERC released the summer 2026 reliability assessment. And we at WEC had provided a significant amount of information to that, and we've worked with them to produce that. There are several pages dedicated to the Western Interconnection and California specifically. So let's go ahead to the next slide. So the summer reliability assessment has risk categories that they publish for each part of the electric reliability organization, and it identifies, it categorizes each region into a risk level. And so that's either normal risk, which in the case of the seasonal assessments means that based on the analysis, it looks like sufficient operating reserves can be maintained under average demand conditions and typical outages and availability of variable resources. Elevated is more of it's a higher risk. Obviously, it is elevated conditions when the demand forecast is above the 90th percentile, or we have abnormally high outage rates, or if we have low renewable availability on those curves of renewable generation. So it's not necessarily an and, it can be an or. There are some subjective parts to the categorization, but generally speaking, that's the criteria that are applied. So next slide. Raja, can you sorry, I'm on the wrong screen. Okay, so our results for the Western Interconnection show that all of our regions are anticipated to show sufficient anticipated reserve margins. So what that means is the anticipated demand with existing resources plus any resources that are scheduled to be online at some point during the summer season. We also do a probabilistic analysis, Monte Carlo type simulation, and of the 8 WEC regions, it did show that one of the regions has a small amount of expected unserved energy, and that is in the Northwest. That probabilistic study showed shortfalls coming in early September in the late afternoon. However, even in the Northwest, those anticipated reserve margins were expected to be sufficient. So it's much more the distribution of where things fall on the resource outage and load distributions. California, the specific numbers for California are shown on the chart in the bottom right, showing those anticipated reserve margins taking into account operating reserves and expected outages And as you can see, the dotted line comes across and it is somewhat higher than the extreme demand. So that's the 50-50 demand plus an increment for extreme demand situations. And California is showing as sufficient, so normal risk. And let's see, the probabilistic analysis, which was run for each region, including California, did show no expected unserved energy in the California region. Next slide. All right, so part of the analysis, part of it is the quantitative, and part of it, which is based on the loads and resources as submitted by the BAs, including the California BAs. So that's the stacking of the resources, the distribution of the loads, the distributions of the resource shapes, but there are also the risks that are not necessarily directly quantified into the analysis. So the ones that you've already been talking about here this morning, the extreme heat, the possibility of loss of load, or excuse me, loss of transmission due to wildfire, capacity shortages, which we're all aware of with the hydropower, and the loads associated with the higher heat. We discussed in our submittal to NERC the mitigation activities. Several regions are engaged in the vegetation management, the PSPF, the safety shutoffs of electricity, and the transmission-related mitigation programs that are in place across the interconnection and in California. We do mention the Santa Ana winds and the risk of the reduction in wind output from overspeeding the turbines. And then, of course, the afternoon declining solar output along with the peaking loads in a heat event being identified as a high risk period. The energy transfers, so WEC did change its modeling program in this year's summer reliability assessment. So we did see an increase in transfers across between the regions within WEC. However, I will add that part of that is a consequence of the modeling transfers. If anybody wants more information on that, I'm happy to provide more. Feel free to contact me. It is essentially that in past years, we were calculating probabilistic transfers in the event that a region was facing unserved energy and unable to meet its reserves. This year, it is also, because it is in part a production cost model, we are also incorporating those economic transfers. So the year-over-year comparisons are not as meaningful. And you will see those if you look at the NERC report. There's a comparison of 2025 to 2026 for all of the measures. And just a caution that the year-over-year comparison this year is not as easy. It's not as straight of a line as it has been in prior years. Cybersecurity, as always, is incorporated as a risk, and supply chain is definitely worth a mention. We continue to see supply chain issues throughout the interconnection and in California, and because our assessment is based on the projected commercial operation date of the resources, delays in that could increase the risk of the resource adequacy risk in California if certain projects get delayed. Next slide. Okay, the hydro, I am not an expert in hydro, but I know we're all aware of the struggles with the drought as discussed earlier, and also with the Southwest region and the reservoirs being at historically low levels. The Northwest, British Columbia, as well as the Northwest United States are actually on average having a near normal water year, generally around 90% to 100%, depending on the region. That water year runs through September. We did have much earlier runoff, which is creating its own set of challenges, whether or not the reservoirs can capture all of that runoff. And then, of course, the early drying of the vegetation. So we also mentioned the Bonneville's, the federal agency's recent order that they will be increasing spill to support fish outmigration this year, and that goes to the end of August. So we did not quantify those in the summer assessment, but it's something to be aware of. And the operational impacts by Bonneville, as far as we know, are still being assessed. So in the Southwest, we do look at the relative share of hydro generation and hydro nameplate capacity in these regions as compared to the Northwest regions and the northern regions in Idaho. It is a lower share, but obviously still a very important resource adequacy risk. And WAPA, in its recent letter to stakeholders, discusses the Colorado River Basin and those challenges there. Historically dry year, total system storage only 36% of average, and that's of course across the basin projects. So again, this is not specifically incorporated as a fuel supply in our probabilistic analysis. It is incorporated by way of historical actual generation patterns and weather years. So that is something to note as well. Next slide. We did do an analysis of resource completions because this does tie into the summer resource build constraints if things don't come online, and just sort of looking at projected builds versus actual builds. This is not specific to summers. This is just an annual set of annual numbers. But the trend of lower completions relative to proposed has gotten closer. The gap has gotten smaller over the last few years. During the pandemic years, obviously it was quite large, which created a lot of concerns. And California has a slightly higher completion rate compared to proposed projects at 69%. So, and in terms of nameplate resources, California has represented 35 to 45% of the completions in the entire interconnection. So thought it was important to note that the pattern is looking better, and we'll stay tuned for this summer for some of the larger projects that are in the pipeline. Next slide. Oh, okay, so as I said, I'm happy to answer any questions about the modeling process or anything else. I will put the SRA, the Summer Reliability Assessment from NERC, in the chat. WEC will also be releasing a WEC-specific summer assessment in a couple of days. It'll be on our website. And any other engagement, please, you can hit the QR code, or on the next slide, there is an email address that you can feel free to use to connect. That's my presentation. Any questions?
Thank you, Brittany. Let's see if there's any questions from Brittany on that assessment. Brittany, I got a question. Can you, going back to the slide, right? What is the elevated risk? Can you explain more? Just curious, the yellow, the orange, right? That color for the
Yes.
WEC Northwest region. Does that mean that WEC anticipates, is there any criteria like, more EAs you anticipate in that pocket, or just curious from your perspective? Yeah.
Correct. On the previous slide, it does show the criteria, and it's the elevated conditions show that in our probabilistic assessment, not just on a straight anticipated resource reserve margin calculation, but on the probabilistic, on the higher ends of the demand and with higher than average or expected generator outages, combined with these three factors in some combination, low renewable availability, that is the scenario that resulted in, and it was actually September 6th at 6 p.m. And then there were some August hours in some of the probabilistic runs. So essentially that's how our analysis got to the conclusion of an elevated condition. And I should say, we worked with NERC on that, and they actually make the final call of which risk is elevated, but we worked together with them and agreed that yes, indeed, our probabilistics show that Northwest does have higher risk on a combination of those factors.
Thank you, Brittany. Did you say hour ending 19 or
It was, yes, hour ending 18, I believe.
18? Okay. Thank
Um,
you.
Not sure, but either way, it was late afternoon, September, and it was interesting. It was quite concentrated there.
Okay, we'll watch out for that. Thank you. That's a good information. Anybody else has any questions for Brittany? Looks like Chris. Yeah. Go ahead, Chris.
Chris Sanford from BPA. I'm curious why, with the time period that we see the highest risk for unserved load in the Northwest, it seems odd that it doesn't transfer down into the California region. If the Northwest is short energy in that time period, then it's not going to be exporting for the solar ramp down.
That is a fair point. And this does have to do, so part of, it all has to do with the resource builds and the, in this probabilistic run, it's possible that you have, excuse me, coinciding high loads. We did run Northwest as its own region. So on its own, California did not show that same elevated risk of expected unserved energy in those late summer hours in the late afternoon. Transfers, as I said, were incorporated. So to the extent transfers were available, they would have been in those probabilistic runs. We're happy to spend time going through it, going through the specifics of it. I frankly was surprised to see the results as well, and we were digging down pretty hard to see what was going on. So and it's always worth taking another look. It's always worth scrubbing the data. We do use the data that we received from the BAs. There are, I believe, 15 BAs in the Northwest that we received data from. One comment I might make is that it seemed to me that there may be some data issues or at least interpretation issues of what qualifies as dispatchable demand response that we have in our model. I would love to work with anybody in the Northwest and take a look at all those numbers and just make sure we're spot on with the underlying data.
Thank you.
And Chris, this is Cody at RC West. What I've been stunned by that might be part of the reason for that is the amount of storage that California's built. Every time I think I know the number, by the time I say it, it's gone up. So I would guess by September that number is somewhere around 20,000 megawatts of 4-hour storage, which is what, 40% of peak load. Just in batteries, it's been just an incredible change.
So just to clarify, so are you thinking then that excess solar just is being stored in California as opposed to being sent north?
Yeah. And why that specifically hour ending 1819 that used to be quite a challenge in California, they're able to bridge that gap much easier into later hours when the load has gone down.
That is a fair point.
Yeah, Lee from Portland, quick question on that, Cody. You guys have a ton of batteries, but we don't see that in your curves for charging or discharging on, we don't see like the 17 plus gigs. Why, I'm seeing like usually about 5 to 6 in that range. Why are we not seeing it all at once?
And Brian might have better answers, but I think I saw it on Twitter. California ISO had, I think, 12 gigawatts of like peak battery simultaneous discharge. So it's like every time I think I know the number, it's exceeding it.
Yeah, Lee, I think installed capacity for batteries right now, we'll cover this in the afternoon session a little more too, but right around 15,000 megawatts. But you're right, I think the peak that I've seen for charge discharge has been in the 10 to 11,000 range. So that could be a combination of things that are still in test phase, maybe not have their full NQC availability. as they're testing through phases and releasing additional chunks of that resource. But I hear what you're saying. We hear about 15, but we only see typically on a lot of the charts, something closer to 10. But I think that's.
Yeah, and I think my question is, it looks like you guys are almost catching up your batteries with your solar. So are we expecting not to see so much northbound this cheap solar because your batteries are going to keep it in state soon?
The market is looking at the Western Energy Imbalance market is going to be looking for price signals, right? So those charging prices, if we have excess energy internal to CAISO BA during that, the solar hours, depending on what the price makeup is, if BPA or others up north are short and those price signals are indicating a higher price, then that it just depends. There's going to be price competition there, right? So if there's transmission capacity available and entities up in the Pacific Northwest that are participating in the WEIM, it's going to look to transfer that power versus probably charging, but it just depends on those price signals.
If I could also make a comment on that, based off of my experience having a large battery fleet, regulation is a large portion of the revenue model for a lot of these battery units. And so there will oftentimes be regulation held off the table. So that percentage kind of lines up with my expectation of what they're holding in margin for that regulation service.
Yeah, that's a great point towards Lee's previous question. Yeah. Thank you.
Good. Thank you. Good discussion. Brittany, good presentation. Let's see if.
Thank you.
Yeah, I see a comment from Sunman from Portland General. Can CAISO provide a general percentage breakdown on how many of the batteries are standalone versus co-located? I don't know, Brian, if you don't have it in top of your mind, maybe later this afternoon session at 11 to 12, right? You can get some of the information shared.
Yeah, Roger, I can do that.
Sanman, I know we have a closed session from 11 to 12. Brian can get that additional information and share the information during that call. Thank you. Good question.
Sounds good. Thank you.
Yeah, thank you, Sanman. Are there any other questions for Brittany? I know we are going a little bit faster. Let's hope more questions for people so we can extend this call. Looks like there's no other questions, Brittany. Thank you very much. Thank you for taking your time to present WEC's summer assessment and addressing some of the questions that the membership have. Thank you again.
Thank you.
Appreciate your support on this. Thank you. As I mentioned, right, we are definitely going faster than what I anticipated. Now, if you want to take a short 15-minute break, it's supposed to be 10, but we'll take a short 15-minute break and go into some of the RC West operation management team preparations for the upcoming summer. And hopefully we can get more questions during that time frame. Thank you. We'll start the meeting around 9:30. This is 17 minutes, but I think we have a lot of time. So thank you. See you guys at 9:30. Okay, time check, 9:29 a.m. We'll start the meeting in 1 minute, 9:30. Start back. Okay, thank you, folks. We'll reconvene the meeting. I know this morning we have seen Amber talking about the summer outlook from a forecasting point of view, and Jeff Fuentes talking about fire potential, fire activity for upcoming summer. And then Brittany talking about from a generation outlook, the WEC analysis that WEC normally performs every summer. So they have talked about, she has talked about that outlook, right? Now, later this morning, we're going to showcase what RC West operations team has been engaged with our TOPs and our BAs in preparation for the upcoming summer. I know there's a lot of activity that gets done for both BAs and the transmission operators. You know, there's more than, Tricia can correct me, there's 24 BAs under RC West footprint and more than 40 TOPs under the RC West footprint. And each of those BAs, right, performs generation assessment. And when I say generation assessment, they look at their forecast, right? Do they have enough reserves for the upcoming summer from that point of view, from a planning reserve margin point of view? And then each of those TOPs also perform a transmission assessment. You know, a lot of times this information does not get shared, but it is a lot more work, a lot of work for the TOPs to actually go and perform a detailed transmission assessment. What does that mean, right? They look at the upcoming summer, they create power flow models, they perform N-1, N-2 studies, and planned outages, the impact of those planned outages, and come up with what are the issues that we're going to see, that we're going to see this upcoming summer from the flows, from the transfers, and then come up with an operating plans, right? So that is really critical from an overall summer readiness point of view, understanding what issues you will see from the planned N-1, N-2 simulations, and develop operating plans, and then share those operating plans with the RC operators, right? So there's a good coordination that happens for Ready this summer. So I'm going to share some details. Obviously, I cannot share it's a public meeting, so I cannot share in-depth analysis of this transmission assessment, but I will give a brief overview to showcase where we are with respect to the summer. And again, I'm Raja Tapidobula, Director, RC West Operations. Let me share I think I'm sharing the screen. Can somebody confirm if you're able to see the screen?
Yes.
Okay,
Yes, we
thank
can
you.
see it.
Thank you. So before I go into those summer 2026, I wanted to do a brief recap of the summer 2025 operations, right? So the RC West system-wide 2025 summer peak load was around 124,870 megawatts, which occurred on August 21st, 1739. And compared to the historical peak load, which is 130, right? Definitely lower than the historical peak load. Overall, summer 2025 has not resulted in major operational concerns or capacity shortages for RC West BA and TOPs, 24 BAs and 40 TOPs. There's no major EA concerns. There's only one balancing area in the footprint that went into EEA3, which is emergency energy alert, right? due to forced outages and derates, and the BA armed the load for contingency reserves, right? It's part of the EEA3 process, but there's no actual load loss that occurred. There's no actual load shed that occurred. It just, they armed the load for the next contingency, right? So that's the only EEA3. So it does definitely, we have some, I mean, as always, right, anytime there's an event that occurs, right, we look at, we do a detailed event analysis, and from that we do lessons learned, and which results in always our process improvements, our tool improvements. But overall, what we have observed is there's an increased, really good coordination between RC West operators and TOP operators, and for a lot of those events, right? We look at the listen to calls, good communication across the board, good understanding how do we want to reduce. Yeah, sorry, there's a chat that come in, and there's good coordination between all of the entities. There's also, we haven't seen major PSPS events or wildfire encroachment related BS outages. In the sense, there were some PSPS events, but we didn't see major transmission loss because of that. There's multiple fires across Northern California in summer months that did result in potential open loop conditions for the next contingency. But again, the operators from the RC West, CAISO, and then BPA operators, right, work together to understand the situation, help manage those situations, and address the reliability concerns. So again, really good coordination. There were other fires in other parts of the system, Western Colorado, Utah, right? And that did result in some potential reliability concerns. And then RC West and SPPRC at the seams, there's really good coordination along with the PAC operators, right? Helping with each other. So that is really key for us. We always train on that, expect good coordination from operators, train on that, and good coordination with the neighboring RCs as well. And these events showcase that the work that we have been putting on with our training team support has been successful overall. There's good coordination. Again, there's a lot of lessons learned from all these events, but overall, we're in good shape from the coordination point of view. So now, yep, and now going to the 2026 RC West Summer Assessment. Again, RC does not do a detailed assessment. The TOPs do it and provide the RCs with their detailed summer assessment, and RC West does look into those, and if there's any questions with respect to the operating plans, reach out to the TOPs. And so far, for the summer assessment that we have seen from a transmission point of view, we haven't seen any major thermal issues in many major overloads that will have an adverse impact on the summer reliability. And the system has adequate reactive margins to manage voltages, which is always a concern, right? And there's adequate load serving capability for expected peak conditions. So these are all the key things, right? From a transmission point of view, what overloads, what transmission overloads you see, and there's a good operating plans that to address those overloads. Yes, there's been good documented operating plans. And then from a load serving point of view, which Brittany shared in her generation assessment too, but based upon what we have seen, there's enough generation to serve the load for the expected peak conditions. But again, this is the expected planned outages, but things can change, right? There's always forced outages in the transmission system. There's always forced outages on generation system. Things can change, and that's where all the coordination work that RC West does with their TOPs help prepare for those situations. And the last, there's no new IRLs, which stands for Interconnected Reliability Operating Limits, have been identified. So far, RC West footprint, we have 2 IRLs, predefined IRLs. Other than that, the studies did not yield any new ones. So those are the 2 ones that we already have, and we have an established processes and procedures to manage those. So another brief overview of the summer assessment, right? Again, California-Oregon Intertie COI is a PAT 66. It stands for PAT 66, WEC PAT 66. It's summer limits from July onwards. The limit is north to south, 5,100 megawatts, which is the standing limit, and south to north, which is a 3675. So it's a full capability is restored. I know there's some outages in June related to transmission upgrade work that is happening. Most of the work will be done by end of June. That's the plan. And once that is done, everything is restored back. So the full capability expected on that path. And Path 15 and Path 26, Path 26 is between the North and Southern California. There's no expected D-rates for the summer. And PDCI, which is the Pacific DC intertie transfer capability, is expected to be normal as well. One change that happened in Southeast Montana, which is around Path 80. So there's a phase shifter there that WAPA had a crossover that has been out for a long time, and they replaced the phase shifter with a series reactor that came into service early this year. With that, we do think it will help the Path 80 operations a bit, so we should expect better conditions there with that. And from a training point of view, this is where Trisha's team does a great job in establishing a good restoration drills. The drills are completed in spring 2026, and what this helps is it establishes a good coordination between the operators, right? Between the RC West operators and the TUP operators that involved in this. It establishes a good communication between them, which will help with any of the events that we see, especially with the fire related or forced outages, and those calls will help us to manage those reliability issues better. I know we have a lot of processes and procedures, but at the end of the day, that operators are the one that has to follow that. And as a good communication, good coordination between them, it helps with good operations. I give a brief overview. I know both Samson and Cody are going to talk more details about the tools and about the processes, how we are preparing for the upcoming summer. But I wanted to give a brief update on one of the situational awareness tool that RC West management team utilizes. Amber's team, who is our forecasting team, they provide a system-wide, WEC-wide, RC West footprint-wide peak outlook, 8-day weather outlook. And what this does is it enables the RC West operations management team to gauge upcoming forecast, upcoming weather impacts, any expected load increases in the certain pockets of the footprint. And then it enables us, based upon that information, we have certain criteria. Once we reach those criteria, it enables us to establish a ROWG call, which stands for RC West Operations Working Group meetings. And we'll invite all the BAs and TOPs across the footprint, and we share that information and make sure that if there's any additional help that the BAs need and with expected forecast increase in that next 8 days, are there any things that we need to do? If there's any planned outages going on, can we reschedule those planned outages? And as well as if there's any path derates, looking into, can we do a transmission reconfiguration? So a lot of those options that we discuss with those BAs and TOPs, so that we can manage their operations during the actual days, right? So those calls does help, and that information really helps us, RC West management team. I also wanted to update the group on a new tool that RC West is testing. It's a AI. Right? Today, everybody's talking about AI, but we have been engaged, our technology team has been engaged with a vendor to test this tool. What this tool is doing is, it is calculating the BA capacity, essentially BA capacity for next day, right? So it's essentially forecasting for us how much extra capacity available after this other load for next day, right? And this enables us to, if everything works, if this tool works really good, if the AA mechanism works, it enables RC West to have a wide area view for the next day for all the BAs in the footprint. And we can work with anytime there's a BA has a problem with load serving expected system conditions, we can work with the BA and provide support to the BAs. And ultimately, that's the goal. We're planning to test this tool this summer. Again, when I say test, it's still in a research mode. The RC West operations management team is going to look at these results. And if it shows up any concerns for a specific BA, we plan to contact that BA management and then work with them and see if this tool is working well, or the tool is not working well, and understand what is the reason, what is the data differences that are occurring, right? So we want to do that research, more of a parallel testing or parallel operations, what you want to call. I know this is still in research mode, but we thought this is a good opportunity for us to test this tool in the summer and in actual system conditions. So we'll definitely share with the groups, appropriate groups, as we get more information from the tool, we'll share with the groups. Apart from that, RC West operations management team, we also have an internal outage coordination calls with all our engineers and RC operators management. And we do discuss the upcoming week outages. And then based upon that, if there's any potential transfer issues or path issues, and if you identify any issues, even before we have a ROWG call, we can work with the TOPs, individual TOPs, and manage those outages, manage those path issues for the summer, right? So this is another tool in our armor that will help us prepare for the summer and things that we can change because still it's in our control, right? So before the actual summer hits. And then RC West, I know, has continued to improve our oscillation tools, oscillation monitoring tools through the stakeholder oscillation task force. We have seen increased local area generators oscillating more with all the increased renewables that is happening at the RC West footprint. We have seen more oscillation, and we have spent a lot of time, a lot of effort, our engineering effort to identify, to develop new tools so that we can quickly identify the source location of these generators and help manage those issues because before they become a bigger system issues. And we have spent a lot of time with improved coordination with our neighboring RCs. I know there's a lot of talk about SEAMs, operational SEAMs. Everybody is concerned or excited, depending upon who you talk with, right? Opportunity to work with. But from an operations point of view, we have a good coordination with our neighboring RCs. And we have bi-weekly calls with the neighboring RC management, right? And we definitely utilize those calls to continue to improve our coordination between our operators, right? Anytime there's an event that occurs, we look at those calls and listen to those calls. And if there's an opportunity for improvement, and these bi-weekly calls with our neighboring RCs help us to improve those. So these calls have helped us quite tremendously. As I mentioned, last summer, we had a bunch of fires at operational SEAMs with SPP, and all those calls were really, really good calls and good coordination between the entities. So I just wanted to showcase that we do work quite a lot on that side. And I think this is the last slide from a wildfire. As you know, there's definitely wildfire impacts to. There's more frequency and severity continues to be concern for utilities across the West. You know, since 2020, I think there's an increased either it's better tools, better monitoring, or more fires are occurring in the last couple of years. You know, there's always the question: is that more, are you monitoring more now? That's why you are seeing these fires more. But maybe it is the case. But we have seen increased frequency on that. And also, we have seen increased public safety power shut-off programs. You know, WEC has some statistics to show that there were 5 TOPs in 2020 that had some kind of PSPS program, and now there's more than 30 TOPs that have this PSPS program. So what does that mean, right? So there's an opportunity for the TOP to temporarily turn off the power to specific areas to reduce risk of fires caused by electric infrastructure, right? So based upon each of the TOP, they have their own criteria, they have their own mechanism, how do we manage those? And when the TOPs make the decision, I wanted to make sure everybody understand that RC does not have a role in the decision making of this. It's the TOPs, individual TOPs criteria, individual TOP decision to take the lines out. And we will never deny the denatization, right? We'll never deny those requests. Ultimately, what we ask our TOPs is, give us information ahead, right? If you're able to let us know ahead, we can do those wide area system impacts and plan for it, right? When the line's taken it out, we can plan for it and develop mitigation plans on those. So again, I know a lot of times we get this question: does RC deny the outage, those PSPS outages? We will never deny a PSPS outage, right? We just ask, give us head information, especially as I shared the statistic, right? There's more than 30 TOPs, because if multiple TOPs across the footprint, pretty close in the vicinity, are taking these PSPS outages, it can spread quickly. It can have wide area impacts, and that's where the RC operators can come in and study it and mitigate it, look at wide area point of view and develop mitigate plans, right? So again, if you have to take it emergency, you'll take it and we'll develop an operating plans. But if you know ahead please let us know. Please let RC operators know, and they can work with you and develop mitigation plans for those. This early coordination is always critical, and we really appreciate that.
There's some questions in the chat, Raja.
Yep. Thank you, Brenton. I think now I can go to the questions. Let me see. Brenton, if you can see, can you read the questions if you're able to?
Yeah, this is, the first one is, my understanding is, I'm sorry, can you hear me? First
Yep,
one
Brent.
is, my understanding.
Let me open the chat. Okay, give me a second. I can open the chat, Brenton. Give me a second. Okay. So I know they mentioned this OATA. There's a question, is the OATA A tool limited to the RC West footprint, or is the full Western interconnect coverage available? Samson, go ahead. Yeah.
Yeah, this is Samson Adigon, RC West. Yes, yeah, right now it is all the BAs in the Western interconnection. And like Raja mentioned, we're still testing and validating the data that we have. And obviously the accuracy of the tool is dependent on the data we receive, even from our neighboring RCs. But yes, it's for the entire Western interconnection.
Thank you, Samson. Chris, maybe you can help me with this question. Saurabh Monga had a question on the NVACI. Is the NVACI maybe 4,600 megawatts? I think it is. Can you confirm that, Chris?
I gotta look that up. I'm not aware of any seasonal D-rate like that, but let me verify that information. I just need a few moments, a few minutes to get that.
So, Saurabh, how about we discuss? We'll try to get the information. I don't think there's any D-rates for summer on that. I was not aware of it too, but we'll definitely check on that and get back to you at 11 o'clock call. Thank you. I think those were the two questions that we had on the chat, but let me open up any questions anybody has here in the room or anybody in the WebEx. Please do raise your hand and ask the question. We'll appreciate. Yeah, David Piper has a question here. Go ahead, David.
Close. Dave Shumlas, Southern California Edison. My question has to do with AI. You said RC is using AI to help monitor BA operations. Is that looking into the California ISO's market runs when it does this analysis and evaluation?
David, Samson can answer the question.
Yeah, so we have multiple phases of the project. The current phase we're in is to use publicly available data. Available to the vendor is OATI. So in the OATI tools such as Oasis, the Western Interchange tool, WIT tool, ECC, outage management system, and then publicly available information on the EIA website. So data submitted by each BA to the EIA site. So all of that is what we're using for forecasting BA capacity for the next day. So it's not like current BA performance, but forecasting for 24 hours ahead, every hour, 24 hours ahead. And then I guess there's discussion that depending on how successful that is, we move on to a phase 2, which would now use maybe market data and internal data. But then that would be more internal to CAISO RC West.
Hey, David, we did share in one of the RC West operations working group meeting. I can forward you that presentation material from that. It does, and maybe there's an opportunity for us as we go through the summer, as we're doing this trial runs, if I can say that, use that word, we'll definitely share with working group members and at an opportunity time. Yeah, I caution again, it is really, I know it's really advanced technology. I know we use AI quite a bit all over the place, but if it works, it's going to be really, really valuable tool. But I caution, right? Because it's a AI tool that it's essentially a research, right? It's based upon the public data. It might not work too. So just caution from that point of view. But I wanted to share that we are testing that tool and hopefully that it can work, right? Which can be really, really valuable tool for RC and sharing with the BA. So thank you. Let's see if there's any other questions on the chat or any questions on the WebEx. Okay, thank you. Oh, was there any question or somebody going on mute? Okay, if not, we can move on to the next agenda item, which is Samson Edigan, RC West Operations Manager. He's going to discuss the summer readiness emergency procedure updates.
Thank you, Raja. Good to see everyone in the room. Thanks for coming out, including all those online as well. So I'll be going over RC West emergency procedures. For many of you, this is more of a refresher and maybe some new items as well, which would highlight with our procedures. And then for some of you, it may be new as well. So feel free to stop me and ask questions if that comes up. Let's see, all right. So let me. All right, so this slide here highlights the preparations that we do as an organization in preparation for the next day. It starts with a daily email that we receive, which actually looks out 8 days out from our short-term forecasting team. We get that daily email at 9 a.m. every day. We review that. RC West management reviews that email. So it gives us a temperature peak outlook for the next 8 days for each balancing area and each region. So we review that, and depending on what it shows, if we're seeing potential for extreme temperatures in multiple BAs, we make a determination to set up an ROWG operations management call. It may not be day ahead, it may be a couple of days out based on what we're seeing. So you will get, your ops management will get an email. And then next, every night at around 1900, the RC operators have a meeting with the engineers, the real-time engineers, day-ahead engineers, to review the operations planning analysis for the next day. They review potential SOLs, the stability limits, the IROs, and they determine the risk, they coordinate with each TOP and BA, and then they also make a determination whether to set up a call for the next day, a regional call. But along with that, based on the information, they update the RC West daily report, which is posted at midnight, every midnight. So that daily report includes what we call a condition status indicator. There are 4 colors. Normal is green, then yellow, orange, red, depending on the risk that we see or we're forecasting for the next day. That will show up in the daily RC report posted at midnight. And then depending on the status of the daily condition indicator, either at 3 a.m. or at 4 a.m. Pacific time, RC West operators will initiate a regional call with BAs and TOPs. We have two regional calls. There is a Northwest regional call, and then there is a South regional call. So the South regional call is held at 4 a.m. The North one is held at 3 a.m. And we would typically initiate that call if we reach a condition orange or red. And then at 6:15 Pacific time, we have a coordination call with all of the 4 RCs. So that's a daily call. It's not dependent on conditions. It's just something we do every day, 6:15 a.m. with the RCs, whether the condition is normal or if it's normal, we just talk about the major outages, what we're seeing, what the temperatures are. We don't see any risk, and it's a short call. If it's there's more happening, then it may be a longer call with all the 4 RCs. But that has been very valuable since the inception of RC West. Okay, next slide here just kind of shows you screenshots of the daily condition status indicator. Like I mentioned earlier, right, there are 4 colors. And, this slide identifies what they mean. Depending on the level of risk that we're seeing, if we're going to be, the risk warrants elevated monitoring, or we do feel like there is actually a risk of maybe BAs declaring EEAs, right? Or there's risk of actual firm load shedding. So, just pay attention to those daily reports from RC West at midnight, and the condition status indicator is usually at the top of the report. And then the bottom half there shows you the peak outlook report, which we received from our short-term forecasting team. We really value these reports, and it gives us an indication of what the level of risk is in terms of temperature alerts. We've been having some internal discussions with our forecasting team to even enhance this report to include, say, like level of load as well. So not just looking at temperatures, but what that means for each BA in terms of peak load as well. So, so this report is really very helpful to us, and it's a trigger. Now, this slide identifies the various energy alert emergency levels that we have that the RC can issue either the day before or the day of, right? So like I mentioned, right, we have these triggers to have these coordination calls, either at an ops management level or at an RC, BA, TOP operator level. The first level there, EA watch, is not a NERC criteria. All of you likely are familiar with the EA 1, 2, and 3. But then we have this EA watch just for RC West. It's a provision that allows the BAs to issue some sort of alerts either the day before. You can even issue it more than 1 day before if you're forecasting that there is a risk, right? So that may be, and we've seen quite a number of BAs make use of this alert, right? This EA watch, just to put it out there that they're forecasting a risk, and maybe they could get help from other entities. Maybe it may trigger some emergency programs within your BA. So that's available to you, to your BA EA watch. And then obviously there are the NERC criteria, EA 1, 2, and 3, which, again, EA 1, all available generation in use. At this point, the BA is beginning to believe that there is risk that, we're going to be utilizing all generation, we're curtailing non-firm, and we may have a problem. So EA1 in real time is declared. And then EA2, load management procedures in effect. The BA is now beginning to maybe use demand response and and other load management programs just to maintain contingency reserves, but the BA can still maintain contingency reserves with these load management programs. But at this point, at EA2 and above, the RC would want hourly updates. So, you know, if you know, the RC will be checking with your BA operators hourly on the status once you're at EA level 2. And at EA level 3 is the highest level, which really now is indicating to everyone that there is risk to firm load. One provision that is available, which many BAs have leveraged at EA 3 level, is not actually shedding firm load, but arming firm load as contingency reserve, right? Firm load that can be removed within 10 minutes. So that's it really been very helpful in RC West history since 2019. Really, there has been very few occasions where a BA shed load actually shed load. I think the last time was probably 2020 or 21 that I think 2020, yeah, that a BA actually shed load. So hopefully this will be the year. Sorry? Another year where we won't. Another year where we won't. Thank you for clarifying that. I want to jinx nobody. For the foreseeable future, yeah, that would happen. Awesome.
Yes. Can we make sure we record Trisha's comment, please? Thank you. No EEs.
It's gonna be good. So anyway, that's it there. Now, another level of emergencies that we declare, which actually we declare quite often too, is transmission system emergencies. And usually the RC will declare a transmission system emergency, which will come in the form of a GMS WEC-wide message, right? For any of these conditions. And there are a few more conditions listed within the system emergencies procedure, but these are the most common, like an IROL, exceedance, or an insecure operating state. We do declare quite a few insecure operating state. Many times it's due to maybe, fires taking out lines, or it could be windstorms. We got storms happen quite a lot too. And then we start declaring insecure operating state. We've, the last time RC West shed load for insecure operating state was 2022 as well. So that's, we declare it, but once that is sent out, that really alerts everybody that something big is happening in a specific TOP area. And who knows, there may be, if it prolongs, then the RC would have to issue a load shed instruction. That's really what that means. And then you have all these other conditions. Then you have, we have, even when load is at risk for the next credible contingency over 300 megawatts, the RC would declare a BES emergency. System separation, islanding, or open loop. We've not had the open loop in a long time, but we go into potential open loop quite often with fires, unfortunately. Really, potential open loop is your one credible contingency away from what we call open loop, which is the entire 500 kVs, the 500 kV path on the western side being opened. Activation of system restoration plan is another criteria. And then the last one, the RC would also send these BS emergency notifications if, like, a TOP has an emergency in their area. It may be localized, but we have a requirement to send a message out within 30 minutes for that TOP as well. So just take note of that. It may be local. Just let the RC know. The RC would send that out within 30 minutes. And then I want just, spend a little bit of time going into RC West actions for WEC potential open loop. you know, this again happens quite a bit, usually in fires on the western side of the system. And the concern is when you have heavy flows on the western side of the system, right? And you lose that connection, which is a strong 500 kV path from north to south, you know, from, you know, BPAs to California, right? The concern is all that flow, or a lot of that flow could transfer to the eastern side of the system, which is weaker, and cause a voltage collapse. So the concern is instability cascading or uncontrolled islanding. More recently, though, you know, we do see heavy south to north flows too. So it's no longer, the heavy flows can be in any direction now. So we've enhanced our procedures to account for both scenarios. And so the concern for the RC is if the flows are too heavy and you lose that entire western side of the connection, there is a RAS called WEC1 RAS, and there's a portion of that RAS called the Northeast-Southeast Separation Scheme that can separate WEC into two islands to protect the western interconnection. That RAS is designed for non-credible multiple contingencies, right? So if you run into situations where fires take one line at a time and then you're one line away from this condition, in that scenario, we really don't want the RAS to operate for the next credible contingency. So the RCs would take action to prevent the RAS from operating. The RCs will work in a timely manner to disable the separation scheme portion of that RAS. So these are the steps. First, we coordinate with the TOPs involved to reduce flows on that western path to 600 megawatts, below 600 megawatts, which is one of the thresholds for the RAS operation. We also monitor our real-time stability analysis tools on that path. The real-time engineers, you know, they work with the RCs to come up with updated limits. So the study limit used for planning studies is 600 megawatts. So we go with that to start with, but then we start running real-time analysis to come up with a more updated number. Many times that number could be in the range of 800, 900, 1,000 megawatts. So at least that gives more room for transfers. And then we coordinate with these key entities, these RAS entities, APS, BPA, CAISO, PG&E, and Nevada to disable portions of the scheme in a timely manner. So yeah, that covers actions we take, you know, in emergency conditions. Especially with threat of wildfires and storms. And next is strategies for restoration when you have major system disturbances. We recently updated the scope of our restoration plan. We're within 2 weeks of publishing that, but we expect to have this for the summer. So normally the restoration plan by default, by the standards, covers like black start scenarios, islanding scenarios. That's what we really train the operators when it comes to restoration drills. But with a lot of large scale events happening on the system sometimes, and you know, multiple TOPs may be affected. They will lose several lines, but you don't have any islands on the system. You know, no TOPs are utilizing black star resources. Does that mean that you would utilize restoration strategies, right, for that scenario? No. So we made it updates to our procedure to clearly address that scenario as well. And when that scenario happens, the RC will be coordinating with TOPs to do an assessment of the system, helping TOPs to identify boundaries of that separation. also stabilizing their system, fixing any SOL issues, gen load imbalance issues, voltage issues, resolving all that. Obviously declaring a BS emergency for those TOPs impacted. Those BS emergency messages are very helpful actually for the TOPs, because when the RC sends that, at least it alerts other TOPs that this TOP is dealing with a large-scale event. Minimize your calls to that POPs. Just don't call that TOP unless for urgent message issues. We'd actually add language to our GMS message to include that. That way the TOP can focus on really just restoring their system. And then the last bullet there, TOPs initiate restoration of BS elements only after coordinated assessment and stabilization is completed and RC approval is provided. So this is something a little bit new just to pay attention to for each of your TOPs. Like, typically when we do restoration drills, the operators just get into restoring their system right away, right? They're blacked out, start restoring the system. But really, we want to emphasize the importance of coordinating with the RC. And the RC may need to coordinate with the neighboring RC as well. And would like to maybe set up a conference call with the RCs involved, the TOPs involved, make sure that each TOP has done their assessment and we've identified the boundaries. And only once all parties have a good understanding of the state of the system, the boundaries, then the RCs give permission to start restoring the system. So the restoration might take a little bit more longer than it normally would, but it's really for the best interest of reliability, wide area reliability. So we added this language into our restoration plan to make that clear, the importance of really coordinated assessment, stabilization prior to initiating restoration. So, and again, these principles apply not just to black star restoration, but just widespread loss of elements. You may not have islands on the system, but coordination is important. I think that is, that's it. Are there any questions before I turn it over to Cody?
Just the quick plug, Samson, also, that we talked at Oversight yesterday about the updates you're making for the restoration plan. We're looking to dovetail that for the scope of the exercises we set up for next year, right? So we've got to have that discussion with training working group and the power system restoration working group to kind of get everybody on the same page, just because it'll be different than what people have expected from past drills.
Yeah, thanks for emphasizing that, Tricia. All right, if there are no other questions, comments, I'll turn it over to Cody Smith.
All right. Hi, yeah, I'm Cody Smith. I'm the other RC West operations manager, working with Samson. And no, in the agenda, it said me and John Marasenko, but I'm going to give him a break since he did all of our restoration drills, kind of dovetail into that last conversation. Yeah, what we're really hoping to do with that is set up each initial event to have some sort of overload, whether that's MVA, voltage, frequency, that you have to fix first before you get into your restoration, to really program people to get into that thought process. Fix what you have first before you try to add to it. All right, into our tool review, and this does get into a lot of our procedures too. We're kind of tying our procedures with what we use for tools to monitor them. As we looked at a lot of fire risk, fire monitoring. One of the displays we have up at all times in the RC West control room is this right here. It's a GIS map looking at transmission in the west, and then it alerts the RC operators anytime we have a new identified fire within 2 miles of a transmission or generation facility. What they're going to do when they see this is contact the TOP, ask if they're aware of it, do they know the level of threat, and then we assess from there. Besides this, we can also see some of the satellite thermal hotspots from a few different technologies. that once we do really get into fire weather concerns, they'll start monitoring that pretty closely. It also shows, as you can see here, radar, the red blotches is fire weather, and even a couple earthquakes spotted in there. There's a 4.4 and a 4.0. So they're looking at quite a few of the environmental impacts on here, but only monitors and alerts for the fires. We can look at, the active reported incidents, fire weather, satellite thermal hotspots, VERS and MODIS, if you're familiar with those. CAL FIRE has a lot better, faster indications. They get to see satellites that are not public. So a lot of times those alerts come faster through those methods. And our specific procedure we have is RC 0410, transmission emergencies due to wildfire. And that says that the TOP shall contact the RC when a fire threatens facilities. Please do that so we can start working on our assessment. If you are aware of a concern, I've had a few instances where we find about pretty large fire impacts later after we call, and we hear, oh, I didn't know you wanted to know about that. And it's, near 7-8 lines. We do. And the RC will also contact the TOP if we see the fire. Make that contact. We can create a new contingency when we do have multiple facilities that are being threatened by a fire. And we've had, I think, N-8s that they'll create on the fly and then see what would the impact of that be. The nice thing about that is now that new credible multiple contingency is viewable in HANA to all the RC West members, and they can see exactly what we're seeing for the impacts of that fire. And your neighbors can too. We'll send a GMS out that gives a contingency name and how to look at the details of that contingency in HANA. It shows the steps of how to open up the contingency details page, and you can see things such as RAS that triggers gen or load loss. That can be very impactful when maybe the fire's in one area, but it's going to drop gen that you're receiving into your area. Big new process change we have is the RC pre-clearance approval process. Typically, we've been doing this, through OMS, day ahead, engineer studies, but a lot of these real critical lines, too much changes between the day ahead assessment and real time that the RCs need to be looking at those outages and approving them closer to the time of the outage. So we narrowed down the scope of what outages we look at. It's not everything. We're looking at outages that impact IROL, stability SOL, or an SOL that requires coordination with multiple TOPs or the neighboring RCs. And all those specific lines, transformers, RASs that require approval are in procedure RC 0320 Appendix A. And it's about 250 pieces of equipment, which really isn't that bad compared to trying to do everything. So for this, the TOP should request verbal approval from the RC operator for those critical outages within 30 minutes of starting the outage. If it's going to push longer than that, we can restudy it, take a new look at it. Currently, what the RCs are doing is the night before, when we identify one of these critical outages for the next day, and we do that through OMS, and we have a PI tool as well that looks at market outages, different ways we can try to view these. The RC is going to call you the night before and say, this outage specifically you need to request approval for. So we're hoping you're aware of what critical facilities you have in your area, but we're also alerting you to that ahead of time too, and you'll be reminded in the morning. Please don't take that outage until we have a chance to study it and approve it. A few more updates to insecure operating state in RC 0310. To be aware, an insecure operating state is essentially a real-time IROL. The standards say an IROL is identified at least day ahead. So for real-time, we call that an insecure operating state, but they're very similar. It also has a 30-minute mitigation requirement once it is declared by the RC. And what we're asking for now is when the RCs see an indication that something may become an insecure operating state, we're doing that validation process to call the TOP and initiate preliminary mitigation actions within the first 15 minutes of that indication in real-time tools. if RC West is unable to invalidate the real-time assessment results within 15 minutes. Sometimes these can be pretty complex, but we don't want to wait 30 minutes before we let you know that we're doing this validation process. We want to speed that up a little bit. Mitigation actions right away are pretty simple. Don't make it worse. Pausing scheduled outages in your area or possibly coordinating with neighbors to pause scheduled outages in their area. Until we can make sure that that's not a real concern, we're going to slow down and not add to the problem. We also split the criteria in RC 0310C, the guidelines for declaring an insecure operating state, into two sections. A lot of it was focused on thermal cascading. If you have an outage above 125%, we're going to go through the cascading sequence and identify, is this going to cascade? But there's more to it than that. It could be severe low voltages. Unsolved contingencies might indicate a voltage collapse. And really the process for those are different, so we wanted to split them. It's a lot clearer now. For thermal cascading, it can be an insecure operating state if the cascading meets any of these criteria. The cascading is not contained within one TOP area as predetermined by studies. If the cascading extends beyond the TOP area and the cascading puts load at risk in a neighboring TOP area, that could be an insecure state. We also want to set a pretty high bar for this since it's similar to an IROL, that total load loss of 1,000 megawatts, unplanned generation loss of 2,000 megawatts, or the cascading leads to non-convergence or unacceptable voltage. And it says, as verified in section 2.3, that's where we go on to the unsolved contingency. So we're looking at the cascading goes non-converged. Now we're going to take that last contingency that didn't converge and verify that. We have this great new automated cascading feature in our RTCA, and this is what the RCs are going to be looking at first. This has sped things up so much for us. If you're running studies of, I see a contingency that's overloading an element at 125%, now I have to see those results once I take out that next facility. Is anything else over 125%? And that could really take a lot of time to go through more than, say, N-4. This new tool, anytime something does show an overload over 125%, it can run a cascading sequence for that up to N-10. If it gets to N-10, we're still converging. Usually somewhere in between there, if it does keep cascading, it is going to non-converge. But it does that every time RTCA runs with an overload over 125%. I see, we got a raised hand.
Hi, this is Sanam Dokle from Portland General. Is this tool primarily for the RC engineers to look at, or can RC West entities also view the results of this?
So far, this is internal only. It is a new tool. I think that would be great enhancement to get this out on HANA. Initially, I didn't know why it wasn't, but it is something. If you do see something in your area over 125%, be aware that the RC has this and they can give you that cascading sequence. Maybe even send you a screenshot on email if you want the whole thing. And it also includes down here, you can see trip gen, trip load, and then RAS actions as well.
Understood. Thank you.
All right, then the criteria for an unsolved contingency, if it's validated with BES impacts. We're looking if the contingency definition that is unsolved is 300 kV or greater, and then fails to solve in offline tools as well. So we're going to use two different assessment tools to try to validate that. If the contingency solves offline or results in 4 or more adjacent greater than 200 kV station voltages 5% below steady state SOL, and the area affected is not a radial network. So we want to make sure it's a broad area impact. It's not just a small radial pocket that's having these issues, and it is impacting the BES. Also, if assessment time is exceeding 30 minutes without being able to invalidate the condition, we worked pretty hard and everything's still turning us towards this is valid. We're just going to declare it valid now, mitigate, be on the safe side. And then if later we show it's not valid or it is a contained pocket, we can lift the insecure state. I know that voltage is 5% below steady state SOL. I think we're going to try to clean up that language to make it a little clear. But right in our RTCA, it's looking at the emergency low voltage limit and giving you a violation of that. And we're just looking at a 105% exceedance on emergency low voltage. So for our monitoring standpoint, it's a little clearer than how the language reads. Wanted to go over some of the available Pi Vision displays. Not all of them that are available, but just kind of the scope of what you have available through the RC portal. One of my favorite ones, because I made it, is this RC situational awareness display. And it gives a really good high-level overview of WEC reliability. And there's a lot of stuff going on here. You can see the ACE in each of the RC areas for WEC wide, load in each of the RC areas. This reserve deficient BAs, if anybody is reserve deficient, their name's going to just pop up there in red. Otherwise, it's going to be blank. You can see the eye rolls, our margins, any of the qualified paths for unscheduled flow, phase shifter tap positions throughout the west, TTCs of paths, the non-eye roll stability paths and their loading, contingency reserves, cascading contingencies, non-converged, and then for our tools, and this will impact HANA too, if our SE or security analysis has failed, and then for how long has it failed. If everything on here is white, we're in good shape. This one's really good at showing you we have issues as things turn yellow, orange, red, progressing issues. Another one, this is more regional focused. We have several of these for El Paso import. This is a conditional stability SOL in Pacific Core area where we have some custom displays to monitor a specific condition. And I want to bring this up too, because if there's some specific condition that you think the RC should be looking at and you'd like a display like this, let us know. Our operators mostly create all of these. If they see something that they don't have as much visibility as they want, they can go create a display and then publish it to production. Another good example is this Western Power Pool zone diagram. If you want to know, you probably have something similar, but reserves in your area, maybe you don't have the reserves in other areas, and the connections between these areas. Then minimum frequency monitoring. As far as I know, we're the only ones who are doing this, and it's been really interesting. This was really created with the concern of, are we going to have enough frequency response in the middle of the day with high IBR penetration? There was a lot of concern really around all of North America for this. Interestingly, the only time we've shown low frequency response has been around 1 in the morning. The time where we don't have high IBR penetration. It's really just been about how much generation total, how much inertia total is on the grid. During the day, we actually have really good frequency response because we see those batteries responding at a rate no other resource has responded at previously. And we're adding to this one too. SunZia is a 3,000 megawatt resource with a DC. So we'll be monitoring both of the poles individually as credible contingencies. And then the bipole is a conditionally credible multiple contingency. So that one would only be monitored if there was a threat to the bipole. And then we can predict what the minimum frequency would be post-contingency. And that's right at the nadir, that lowest dip. Yeah, question?
Yeah, Lee from Portland. Cody, you mentioned inertia. You guys are watching system inertia?
This is a TSAT tool that is, and Raj has more.
Yeah, I think, Lee, we are monitoring the post-contingency frequency response, essentially the impact of the inertia, right? We are not directly monitoring the inertia. We have those numbers, but this is essentially the impact. If the contingency happens, right, and if your inertia levels are low, your post-contingency frequency response is gonna hit the UFLS threshold, right? Ultimately, that's where the process has been developed so that we don't go anywhere near the UFLS schemes. Yeah, in a way you can call it inertia, but we treat that as a post-contingency frequency response using our transient stability tools.
Okay. I don't want to get off on a tangent, but any future plans for inertia monitoring or looking for inertia issues?
I mean, this tool essentially, right, the impacts of low inertia, right? Ultimately, that's what we are trying to monitor, right? The impacts of low inertia is how it's evident you have a contingency that happens, right? And how low the frequency drops before it picks up, right? Before your primary frequency response, right? And then your batteries can pick up. So ultimately, we are monitoring that. So in a way, this covers the question that you have, Lee, what we're trying to address. Thank you.
Yeah. One other question, I've said this before, I used to love you guys had the big diagrams of the whole area available in Pi, and I think maybe it was too many points to cover. You guys have that in EMS that you watch, or you don't have a big a screen like that for the whole WEC anymore?
We have a WEC overview Pi. If that's not available on the portal, I'm gonna go make sure we can share that because we have it. And it shows balancing ACE and transmission line outages. I really like that one. So in EMS, it's broken down area by area. We don't have as complete of a display for the whole area. It's usually better to go look at Utah. If we want to look at an issue in that area. And Kaylin, who's here, one of our RCs, has done a lot of that work on making those displays. So any other questions afterwards, I'm sure he could help answer for you.
Great. It was the Pacific Northwest one that I really liked.
Oh, a lot of those individual area ones have been removed because they weren't getting updated. We did create good EMS displays now that we did replace those with. They are available as SVG overviews in HANA. The only problem is they don't have any telemeter data on them. They just show you the picture. But you would get outages. You could see lines in or out of service.
Okay, thanks.
Hey, Lee, to add one more point to your question, Lee, we're also monitoring most of the largest contingencies across the Western Interconnect, right? I think we work with our neighboring RCs as well because ultimately we have the full network model, right, for the Western Interconnect. So we're able to do this in real time. So when you see minimum frequency, it's a post-contingency frequency response using our transient stability tools to identify the inertia concern. So, and we do share with our neighboring RCs anytime we see that information. Thank you.
Yeah, as I was thinking about it, if we just have an inertia number, is 60,000 inertia good? Is 40,000 bad? I think what's great about this is it does give you what is the result of that inertia with the resource losses that you could have to make it quite usable. And we've benchmarked this against, recently we had a major generator outage, and you could go look at what frequency did go down to using PMU display and what were we predicting. And it's been pretty good at it of getting really close and actually just a little on the conservative side, which is good. I wish I would have remembered I did that. Now you can see it a little clearer. Okay, that's it. Sure.
Wanted to go back, this is Will Ragsdale, SDG&E. The cascading test that you mentioned, the new tool, that sounds great for real time. I just had a quick question on, with consideration of how quickly things can change between the 5 and 15-minute markets, and we have all these wonderful IBRs and batteries that can move very quickly. Do we have the capability to catch like a 5 or 15-minute instance of an event that could exceed that 125% overload, and maybe by the time we start looking at it, it's already resolved? But is it possible to kind of go back in the past and say, hey, we were in an insecure operating state for a certain amount of time? I'm sure it's more of a, intended to be declarative for future and, current mitigating actions, but kind of if something pops up and then is resolved quickly with, automatic market actions or other adjustments on the system, is that something that can be that the RC or the engineers looking at the studies, the power flow test, because I know there's a reference to it in RC 0610 as well, and how that's determined before you get to RC 0310 on declaring the insecure operating state. So I just wanted to know if you could clarify a little bit more about how quickly that test and that declaration can happen, and if you can kind of even go back and retroactively say, hey, we were in a bad spot, but we fixed it. Is that possible?
We don't look much at the market from the RC
Sure.
perspective. There's some minor bits, especially now as we get into ARs, we can look at future ratings too. The forecasted ratings will be in the market, where we just get real time in our real time tools. So there's some ways we're starting to view it a little bit. But yeah, I'd say there's definitely probably been instances where an insecure state has been mitigated before it was declared.
Yeah.
But we don't go in the past and then declare that would have been an insecure state.
Right.
It's just if we're still in one and we need to mitigate for it.
Gotcha. Thank you.
Yeah, the market is a good tool to see what's coming up.
Thank you. I think one good question from this is, I think the cascading, right? I think especially during fires impacts, right? I think this might be a really beneficial tool. So we'll definitely take a look into that, whether we can add it to the HANA, right?
Yeah.
This tool, I like that. Yeah, thank you. But again, I think as Cody mentioned, right? You guys are aware, make sure your operators know that. Ask the RC anytime there's a high overloads, more than 125%, is RC seeing any of those studies, right? The results from those studies, definitely make sure your operators are aware of that so they can reach out to RCs. Thank you. Thank you, Cody. I think that we are done with the presentation on the public session of the summer readiness. Any questions from anybody online? We'll post this material on the public website, RC portal public website. And brief summary of what we have discussed this morning, right? We had a great presentations from Amber on the expected forecast, weather conditions and forecast. Looks like it's going to be a little bit hot in some of the regions, forecasted conditions, and which means higher load. And there's also from Chief Jeff Fuentes about the fire potential, as well as Brittany Andrus from WEC on the generation assessment. So really good information that will help us with plans for our upcoming summer. And last but not least, I want to thank my team for coordinating all the TOP studies, getting those studies done, and sharing, and the TOP is sharing those transmission assessment results. A lot of work. Believe me, it's at least a couple of months of work every season for those TOP engineers to perform those studies and provide those detailed results to us, and which will help us looking into any operating plans that we need to evolve. So really appreciate all those efforts. And I want to appreciate Tricia Johnston's team for setting this up and getting us ready for this session. So which will help enable us to showcase what we have done and all the changes, procedures, all the communication coordination changes that we have made to operate for the upcoming summer. And hopefully there's no EAs, as Tricia mentioned, for the upcoming summer. But if there's EAs, I'm confident that the RC operators are well set up to work with all the TOP operators and manage those, and the BA operators to manage those. But again, the fire will change. And we have seen some fires that causing a lot of issues, especially the open loop threats that are always there, right? With the two lines, if it takes two lines out, the next contingency can make the open loop anywhere, right? Across the footprint. And that can cause flows all over the place. And I'm confident that the team is well prepared for it. And thanks to RC management team for that. So that I can end the call and give back 20 minutes for you. I know we have a separate session at 11 o'clock for the balancing areas. It's a closed session, and the BAs and TOPs. The separate link has been sent out. Ping us if you have not received that invite. Okay. I know there's sometimes depending upon the list who sends the list, your name might not appear, but there's going to be more discussion surrounding each BA preparedness, and we are hopeful to learn from all the BAs in the next session. Thanks for everybody that joining in today's call. Hopefully it was worthwhile your time and apologies for the small snafu on the 7:30 time. 7:30 was supposed to be breakfast, but for online people, it's not, right? So apologies for it. We'll definitely fix that going forward. Lessons learned. Thank you, guys. Have a good rest of your day.